Hello, everyone. Yeah, welcome to our today's class. Um, in our discussion today, we are going to be looking at another example in our discussion on linear and quadratic problems using graphical method. You know fully well that there are problems that like the ones I did last time. There are those that the parabola or the curve is like this, is u-shaped, okay, and there are also some that the curve is n-shaped, okay. So that's why I needed to do up to 3 or 4 different examples, or as much as we can contain, so that we can be able to see the 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 differences in these problems, so that one can be comfortable enough to tackle a problem under exam situation. Okay, so in our today's discussion, we are going to be looking at another problem, and this one says, it says copy and complete the table of values for y equals to 4 plus 2x minus x squared. For this interval, if you watch here, you realize that this this time, eh, this term that the coefficient is negative, you're going to see the impact in the nature of the curve it is going to produce. Okay, so you say using the scale of 2 cm uh, for 2 units on y-axis and 2 cm for 1 unit on x-axis, draw the graph of that problem. Okay, it says on the same graph and using the same scale, draw the graph of this is the linear one. Okay, I'm trying to bring these problems together so that one can be comfortable enough to do a typical of it in the exam. Solve the equation this equals to 0. These are the sub questions that follow after you must have done the graph. Okay, and then you say what is the maximum value of what is the maximum value of what is the maximum value of, let me look. Okay, it says what is the maximum value of y equals to 4 plus 2x minus x squared. I'm trying to project this in a way that you can be able to see clearly what I'm doing here, and the corresponding value of x. So what's the maximum value of this? Then using your graph, solve the pair of simultaneous equations. This is a pair of simultaneous equations we are going to be solving. Okay, so like I said earlier, like I said before, the first thing one will do here is to make the table of values. In order to save time, I have already made that, but I'm going to explain it to you so that you understand what I did there. I'm going to explain how we got, these values. I am sure you are seeing it clearly. So you can see here, table of values for y equals to 4 plus 2x minus x squared. Okay, so these terms here, okay, one have to bring them and put them here. Okay, so you put them here, starting with this is 4, this 2x, this is minus x squared, so we represent them here. 4, I'm teaching this thing in a way like I'm trying to explain it to a layman, so I have to be very detailed for what I'm doing here to profit someone. So you put 4 here, you put 2x, you put minus x squared, and then y, the y values. So 4 is a constant, so we have to write 4 on this same line. Okay, we will repeat the values because it's a constant, then we are not multiplying it with anything. Then you have 2x, like I said earlier, these are the x values, so it's just like 2 is multiplying each one of them. So you can see that 2, when x is minus 2, 2 times minus 2 will give you minus 4. When x is minus 1, 2 times minus 1 will give you minus 2. When x is 0, 2 times 0, 2 times 0 will give you 0. When x is 1, 2 times 1 will give you 2. That's how you go through and get all these values. Of course, 2 times 2 times 4 will give you 8 here. Okay. Now, check out this. This is minus s squared. Minus s squared. I said some time ago that you do something like this. Minus, and then you create a bracket, and then you square it. Okay. So, when you now square it, so that it can accommodate any of these x values. Okay. So, when you take minus 2 and put there, you realize that if you put minus 2 inside this place now, minus 2 squared will give you 4. So this minus will affect that 4 and still return it back to minus 4. So that's why if you look here, you realize that under minus 2, you have minus s squared being minus 4. Okay, do you get it? That's if you put minus 2 here. Oh, so that minus 2 now, will become 4, and then this minus will affect it and return it back to minus 4. So the same thing is applicable here. So this is minus 1. Minus 1 squared will give you 1. So minus into that will give you minus 1. So that's how we're able to get all these values. I'm sure that explanation is very clear. This is minus 16, because under that you can see 4. You can see 4. So 4 squared will give you 16, and then minus into that 16 will give you minus 16, as we have here. Okay. So that's how we're able to get all those values. And then when we are done with the values now, we can now be able to make the graph. But before then, I want us as well to look at the linear part. This linear part now, if you watch here, you realize that the value is here. This is 2. This is table of values for y equals to 2 minus x. So these two, I'm sure you're seeing that these two will be written here. Okay. And then this minus x will be repeated here. Okay. So 2 is a constant, it will be written across. And then minus x simply means minus multiplying all the values of x. So it is just like taking the negative of all these values. So of course, the negative of minus 2 is 2. 0, 0. The negative of 2 is minus 2. The negative of 4 is minus 2. You know, I didn't pick all the points because it is linear. And for the fact that when I start making the plotting, all of them will fall in line. So I don't need to write from minus 2, minus 1, 0, 1, 2, 3, 4, and then according to the interval provided for us. So just any of these points, can give us the information we need to make our, graph. Okay. So when we are done with this now, the next thing we do is to graduate this graph in a way that, let me position this thing very well. I hope you can get this clearly. Okay. Okay. I trust God this is going to be very clear to us. I hope so. Okay. So let's go. So in order to graduate this graph, the first thing I do is I try to look at the maximum value on this table of values. Look at the maximum value. The maximum value here is 5. Okay, is 5, and the minimum is minus 4. And they also give us a scale. They gave us a scale to use in this question. They say we should use on y-axis. We should use 2 cm for every 2 units. 2 cm for every 2 units on a y-axis, and 2 cm for 1 unit on x-axis. So we are going to position those stuff now. We're going to put in them in place. So I will now try to see how this is 2 cm to 2 cm. How 5 can be accommodated on this? Assuming I choose somewhere here. Okay, to be my origin. 1 2 3 4 5. I think that is accommodated on the positive side. And from here I have minus 4, which is the minimum on the table, minus 1, minus 2, minus 3, minus 4. I think that side is also accommodated. So I think I'm going to use here as my origin. Now what about x-axis? The interval ranges from minus 2 to 4. So if you also check here, you realize that the points on the negative part of x-axis is smaller than what you have on the positive axis. So that is also going to be put into consideration. We're going to need more space this way. So let me check 1 2 3 4. I think that's okay. And then on this side, minus 1, minus 2. I think that's okay. So I can now use my ruler and position these things. Okay, this is what you are expected to do under exam situation. Okay, you position these things, and I'm sure you are citing what I'm doing here. This place is going to be 1 2 3 4. This is my x axis. Okay, and then this place is minus 1, the next 2 cm, minus 2. Okay, this is the origin. This place is 1 according to the information they given to us, the scale given to us to use. So here will be 1, here will be 2, here will be 3, here will be 4, and the next will be 5. This is my y-axis. Okay, and then down here will be minus 1, here will be minus 2, and here will be minus 3, and here will be minus 4. And I think you saw that clearly. So having done all these things now, let me bring it closer. I'm sure somebody is citing what I have done. Look at it very well. Look at it. See the origin. And inside the origin there. Okay. Minus 1. After 10, within here you have 10 blocks. Please, I did a video that explains the reason why these things have to be checked. You can check out on that video and see the danger of not getting it right here. This should be 10 blocks. This should be 10 tiny blocks in between that make up the 2 cm, then down to 4. So here we go. Having made this table, we can now start plotting the. Having been able to explain this table, we can now be able to start plotting the points. So look at the first point there. It says when x is minus 2, y is minus 4. Okay, so we come here. Look at x being minus 2. Let me bring it closer. Look at x being minus 2. Okay, x being minus 2, y being minus 4. So this is y, minus 1, minus 2, minus 3, minus 4. So we're going to follow this line and get their point of intersection, which is here, and then mark it. So we mark that point of intersection when x is minus 2, y is minus, no, this place is minus 3. It should be down. So it should be down here. Okay, look at it. When x is minus 2, okay, y is, look at minus 4 here. Look at their point of intersection. You mark that place. Okay, the next is when x is minus 1. What is y? Y is 1. So look at x being minus 1, then y is 1. So that will be here. Okay, all right. So when x is 0, y is 4. When x is 0, y is 4. So you also come here. When x is 0, that's the origin. Use it and go up to 4. That's this point. Okay, right? The x coordinate is 0 and the y coordinate is 4. So look at this. When x is 1, y is what? 5. So you come here, you check out this. When x is 1, okay, y is 5. So you follow this line, and go up and look at 5 here. You come here, see the point of intersection, you mark it. Okay, I hope you can see that clearly. All right. When x is 2, y is 4. When x is 2, look at x being 2. Okay, now go up to y being 4. Look at 4 here. Okay, you follow that line and come to the point of intersection and mark that point. When x is 3, y is 1. So we'll come here. When x is 3, look at x being 3 and y being 1. Okay, this is 1. Look at the line for 1. You follow this place and get their point of intersection here. So at this point, the x coordinate is 3, the y coordinate is 1. So finally, when x is 4, y is minus 4. So if you come here, you see that x is 4 here. That x being 4. Then if you check out this place, you can see where y is minus 4. So you follow that line and get their point of intersection here. This is their point of intersection. You mark that place. You mark it. Okay. Now we can use our flexible ruler or something that is a flexible ruler or French curve or whatever to join these things, join these points. Okay, you join the points. So I will join them now. We join them. Try and be careful, especially at this point where this passes through the x-axis, because what happens there is going to be very important. So we have to be very, very careful at that point. Okay, so I have to be very, very careful and don't allow this thing to shift. I'm sure I got something that looks straight there. No, I will not take this. So this has to be much more straight. Stretch it out much more straight. And this point can use okay, so you can now join it. Okay, all right. That point is still shifting again. It's shifting again. We just need to be very, very careful at that point. So the reading that need to be okay. I think I've seen it. How it went there. I can use my ruler and make it up. Okay, it's at this point. Okay, so this side as well. Join this side. So this may not be, for the fact that it's not quite a tedious work. Just get something that is flexible, that can produce a curve and use it. Okay, and then be careful where at this point where this line is going to cut the x-axis, because that is the point that's going to give us the solution to the problem. Okay, This is too flexible. Let me use my ruler. I think this place is straight somehow. Yes. Yeah. But there's something I'm trying to verify here. So there's a shift here. I mean, select shift there. Yeah. So when you are through with this is how it is going to. I hope you can see this graph very well. This is how it is going to look like. Yeah. This is how it will look like. So you can see the maximum point. Okay. You can see that peak. You can see that point. Okay. From there, one can be able to get the line of symmetry to this parabola. Okay. So there are so many things that we are still going to study on this. So I'm not going to. Let's quickly go down to the sub questions. We may not be able to do everything in this graph at once because of a time factor. So I have not put the title. Let me put the title. Say graph of students normally forget this. Graph of y equals to 4 plus 2x minus x squared, and y equals to 2 minus x. So this is the title. The scale is 2 cm equals to 2 units on y axis, and 2 cm equals to 1 unit on x axis. So this is the scale we used. So when we are done with this now, I'm very, very hopeful somebody will see. The most important thing is for somebody to be able to see this thing clearly. Okay. All right. Now the next thing is for us to answer the sub questions. Look at the sub questions that are given to us here. This one says it says on the same graph and using the same scale, draw the graph of. So we have not even drawn the graph of the linear. So let's do that quickly. When x is -2, y is 4. -2 against 4. I think this is -2, and if you follow that point and go, this is 4 here. This is 4. You follow that point and get their point of intersection. -2 for x and y is 4. Next is when x is 0, y is 2. When x is 0, y is 2. That's it. Okay. When x is 2, y is 0. When x is 2 here, y is 0. That's the mark it at that spot. When x is 4, y is -2. When x is 4, this is x being 4, y is -2. -2 now will be on this negative part. Okay, so this is -2 for y. So their point of intersection is here. Mark that. So this is a linear graph. The points have to be on the same line. They have to. So make sure they are connected. All right. I think you can see that very clear. So we have been able to make the linear graph as well. So you say y, this is graph of y equals to 2 minus x, and this is a curve representing y equals to 4 plus 2x minus x squared. All right, sub questions quickly. The sub questions is it says yes, ci solve the equation 4 plus what 2x minus x squared equals 0. What does that mean? I have explained this in severally that This is the curve representing that equation, and it simply is asking us where did this curve touch the x-axis. So this curve, this quadratic problem has distinct roots, meaning it touches the x-axis at 2 points, here and here, here. And then this is where the critical issue lies, because we need to know now how to read these, tiny blocks. Now you realize that from here to here, which is 1, and there are 10 tiny blocks inside it. And if there are 10 tiny blocks inside it, 1 divided into 10 will give you 0.1. To give you 0.1. That is to say that if here is 1, here is 2, we are looking at that point, it touches the x-axis. Here is 2 now. Now here is 3. Can you see where it touches the x-axis? Here. And this is 3. So this will be 3.1, and this is exactly 3.2. Let's go to the other side. Okay, look at here. This is 0. Can you see this is minus 1? You see this is minus 1.1. You see this is minus 1.2. So the solution, if you are answering that question of CI, you will say the solution of y equals to, or y equals to 4 plus 2x minus x squared lies at x equals to, so that point is minus 1.2, and x equals to, on the positive side, 3.2 as well, 3.2. So this is the solution to that one. I am sure it is well understood. Even though I'm trying to be a little bit fast, I'm also considering your knowledge, your understanding of what I'm doing here. That's basic. What again do we have here? What is the maximum value of this and the corresponding value of x? So the maximum value is at the peak, at the peak, the highest, the maximum point of this curve. Look at it there. Now if you follow that point, and of course that's the line of symmetry, look at it, it's at x being 1, so the maximum is at y being 5, okay, and x being 1. So CII, the maximum value of y equals to 4 plus 2x minus x squared is at y equals to 5, and the corresponding value of x is where did we get it? That's 1, is 1. Okay. Oh, hope you saw what I was doing. Look at it too. Can you see that? The maximum value of, don't be offended if you didn't see what I was doing. Okay. Is y equals to 5, and the corresponding value of x is 1. Okay. Now what again do we have? What again do we have in the question? Finally, I hope I have not gone across 20 minutes in this discussion. Let me see. Using the graph, solve the pair of simultaneous equations. In the last discussion, I have also explained to us the meaning of this. I have told us before, but let me say it again in case you're watching this video for the first time, that when logically, if I say 10 is equals to 5 plus 5, and I say 10 again is equals to 4 plus 6, is it wrong if I say 5 plus 5 is equals to 4 plus 6? Is it wrong if I say so? No, it's not wrong. It's a very logical statement. Okay, it's a very logical statement. Now, what if I now say that y is equals to 4 plus 2x minus x squared, and also say the same y is equals to 2 minus x? So is it wrong if I say, if I now make a logical conclusion and say that 4 plus 2x minus x squared is equals to 2 minus x? It's not wrong. So the implication is that I am asking you, when I ask you to solve this pair of simultaneous equation, I'm asking you, where is this quadratic equation equal to the linear? Where is the value of this equal to the value of this? Okay, where is this, which is being y, is also this being y? Where are they equal? And you simply can find it at the point of intersection of these two, graphs we've made. At the point of their intersection, if you look here carefully, you will see where this intersection lies. And if you also look here, down here, you also see where this intersection lies. You can see where the intersection lies. So the simple thing you do is that you make a line to y-axis and make a line from that point to x-axis and determine what the values are. Do it the same thing this way. Okay, let me quickly get my ruler and do that. So you watch me do it. So with my ruler now, I will join this. I'm sure you are seeing what I'm doing here. I will join this to the x-axis, mark it, and get it down to the x-axis. And then here as well, this is a critical point. You have to get this. You get it. You must get it. Now on this side as well, the point of intersection is this. Okay, take it to the x-axis. I hope you saw that. And then from that point as well, you take it to the y-axis so that we can read what the value is. Okay, look at it. Look at it. Now, what's the value here? The value here is, let me get my writing material quickly. I will answer the question and say, that's question number what now? D, question number D. Question number D. I'll say the solution to the pair of simultaneous equations lies at, the first point is x. The value of x here, is, this is 3, 3.1, 0.2, 0.3, 0.4, 0.5, 3.5, x being x equals to 3.5, comma, y there is, I hope you can see this, y there is, the corresponding value of y there is, this is -1, and from here to here is 1, meaning each tiny block is 0.1 as well. So -1, -1.1, -1.2, -1.3, -1.4, -1.5. Y there is -1.5, comma, go to the other part, the other point. Now here is 2, and this is 2.1, 0.2, 0.3, 0.4, 0.5, 0.6 and half, 0.65, 0.65. So, and y equals to 2.65, comma, x, the corresponding value of x on that part, on that side is, if I follow here, point of intersection, and come down here, this is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So this, you remember, this is on the negative axis. So this is minus 0.6. This is minus 0.6. So, and x equals to minus 0.6. Please watch this video again and again so that you can be able to understand my explanations. Please, the explanations we have here, I said again, is not exhaustive. Remember, we are still going to come back to this graph to determine the gradient of this graph, both the gradient of the linear graph and the gradient of the curve. Gradient is going to be a subject of its own. I'm going to discuss. Time will not permit me to do everything here. What about the line of symmetry? Okay. What about uh, the nature, the characteristics of this curve? Some of those things we are still going to look at them one after the other. Has this video been of help to you, my friend? Click on the like button and subscribe to this channel so that you can be able to get our updates as we move on in this project, and yeah, uh, click also on the notification button so that you can be notified when we update and upload our videos. Okay, so remember, I'm still coming back to this graph again. I'm still going to do another example. I want to do up to 5 different examples in this case, so that my students out there and my possible colleagues out there, we can share our knowledge and share our impact in the society. This is nothing, there's no other way we can help humanity than through what we can do, and what we can, be able to offer. Thank you so much for watching this video. I remain your brother Victor Odigoma Ohia. God bless you, and stay put for the upcoming videos we are going to be doing. God bless you.